Today we are going to discuss about hydrogen peroxide. It is used as an antimicrobial agent. The chemical formula of hydrogen peroxide is H2O2. Synonym of hydrogen peroxide is oxygenated water. It is discovered by the scientist L.J. Thenard in the year 1815. So it is usually available as hydrogen peroxide solution 100 volumes and hydrogen peroxide solution 20 volumes. So it is a weak acid with molecular formula is H2O2. Molecular weight 34.02 gram per mole. So it is an unstable compound and it is rapidly decomposed such as in the presence of catalysts such as silicon compound, metal oxides, dioxides and colloidal metals. The process of decomposition of hydrogen peroxide to oxygen and water is increased by illumination. So hydrogen peroxide is easily decomposed in the presence of light, water and oxygen. The next is the method of preparation. It is prepared by either two methods, by non-electrolytic method and by electrolytic method. So by non-electrolytic method, it is prepared from either barium peroxide or sodium peroxide. So in the first method, barium peroxide is made into a thin cream with water. This is added slowly with constant stirring with dilute sulfuric acid, which should be kept cooled in ice. BaO2 plus dilute H2SO4 gives BaSO4 plus H2O2. Then hydrogen peroxide can also be prepared by decomposing barium peroxide either by using phosphoric acid or by passing carbon dioxide. So BaO2 plus CO2 plus H2O gives BaCO3 plus H2O2 or 3BaO2 8H2O plus 2H3PO4 gives Ba3PO4 twice plus 3H2O2 plus 2H2O. Then second method by non-electrolytic method is the decomposition of sodium peroxide with sulfuric acid at low temperature around -2 degrees centigrade. So sodium peroxide treated with ice cold dilute sulfuric acid, it decomposes to give sodium sulfate and hydrogen peroxide. So these are the non-electrolytic method of preparation of hydrogen peroxide. The next one by electrolytic process. So commercially hydrogen peroxide is prepared by electrolysis of sulfuric acid followed by vacuum distillation. So in the first step peroxide sulfuric acid is formed, which is heated. It will give Carros acid or peroxysulfuric acid H2SO5. Then Carros acid or peroxysulfuric acid on hydrolysis, it will give sulfuric acid and hydrogen peroxide. So in the first steps, 2H2SO4 upon electrolysis gives H2S2O8 plus H2, that is peroxydisulfuric acid. Then in the second step, H2S2O8 upon heating gives H2SO5, Carros acid or peroxysulfuric acid. Then in the third step, H2SO5 on hydrolysis, it will give sulfuric acid and hydrogen peroxide. So this method of preparation is called as electrolytic method of preparation. So next is the properties of hydrogen peroxide. So colorless, odorless and bitter taste liquid. The boiling point of hydrogen peroxide has been extrapolated as being 150.2 degrees centigrade. In practice, hydrogen peroxide will undergo potentially explosive thermal decomposition if heated to this temperature. Then it is miscible with water but soluble in either ether or alcohol. It is decomposed by many organic solvent, alkaline media, metallic solution like copper, iron and manganese. It is stable by add small amount of sulfuric acid and H3PO4. Then coming to the chemical properties of hydrogen peroxide, it acts as an oxidizing as well as reducing agent in both acidic and alkaline medium. So the first property, oxidizing property. So note that oxidation reactions takes place only in the presence of acidic or alkaline medium. So some examples for oxidizing property of hydrogen peroxide is when potassium iodide treated with hydrogen peroxide in presence of sulfuric acid, it oxidizes to iodine, potassium sulfate and water. 2Ki plus H2O2 plus H2SO4 gives I2 plus K2SO4 plus 2H2O. Another example, when potassium bromide treated with hydrogen peroxide and sulfuric acid, potassium bromide oxidizes to bromine plus potassium sulfate plus water. 2 kBr plus H2O2 plus H2SO4 gives Br2 plus K2SO4 plus 2H2O. Then third example, black lead sulfide react with water, it oxidizes to white lead sulfate. PbS plus H2O2 gives PbSO4 plus H2O. Then another example for oxidizing property is ferrous sulfate oxidizes to ferric sulfate in presence of hydrogen peroxide and sulfuric acid. To FeSO4 plus H2O2 plus H2SO4 gives Fe2SO4 thrice plus H2O. So it oxidizes many organic substances like hair, fibers in textile industry. So its dilute solution has decolorizing and bleaching action. So that is about the oxidizing property of hydrogen peroxide. So next we are going to discuss about the reducing property of hydrogen peroxide. So first example is it reduces silver oxide to metallic silver. Ag2O plus H2O2 gives 2Ag plus H2O plus O2. So here the silver oxide reduces to metallic silver in presence of H2O2. Then another example, it reduces potassium permanganate to manganese sulfate and potassium sulfate and oxygen in presence of an acidic medium. 2KMnO4 plus H2SO4 plus 5H2O2 gives K2SO4 plus MnSO4 plus 5O2 plus 8H2O. So it reduces potassium permanganate to manganese sulfate and potassium sulfate. So decolorizes the potassium permanganate with liberation of 5 molecules of nascent oxygen. The third property is weak acidic property. So hydrogen peroxide is slightly acidic in dilute solutions. So when react with metal hydroxide, it will give corresponding salt. For example, hydrogen peroxide treated with sodium hydroxide, it will give sodium peroxide. Then hydrogen peroxide when treated with barium hydroxide, it will give barium peroxide. Then hydrogen peroxide treated with sodium carbonate, it will give sodium peroxide. That is example for weak acidic property of hydrogen peroxide. So these are examples for chemical properties of hydrogen peroxide. It acts as an oxidizing agent, it acts as a reducing agent, and it has weak acidic properties. So next is test for identification of hydrogen peroxide. So first take a small quantity of hydrogen peroxide, then potassium permanganate and sulfuric acid. So here the potassium permanganate is decolorized by acidified hydrogen peroxide. So that is the identification test for hydrogen peroxide. 2KMnO4 plus H2SO4 plus 5H2O2 gives K2SO4 plus MnSO4 plus 5O2 plus 8H2O. A small quantity decolorizes acidified KMnO4 with evolution of oxygen. Then test for purity, acidity and non-volatile matter. So acidity is tested by titrating the sample with 0.1 molar sodium hydroxide using methyl red as indicator. The non-volatile matter, that is tested by evaporating a solution on water bath and drying at 105 degrees centigrade and take the weight. The next is the standard. So hydrogen peroxide solution 100, it is usually available as hydrogen peroxide solution 100 volumes and hydrogen peroxide solution 20 volumes. So here the hydrogen peroxide solution 100 volume contains not less than 26% and not more than 28% weight by weight of hydrogen peroxide, corresponding to about 100 times in volume of available oxygen. So hydrogen peroxide solution 20 volume contains not less than 5% and not more than 7% weight by weight of hydrogen peroxide, corresponding to about 20 times its volume of available oxygen. So next we are going to discuss about the pharmaceutical uses of hydrogen peroxide. So it is used as a strong oxidizing agent. It gives nascent oxygen, used for bleaching, and as an antiseptic and germicide, used for cleaning cuts and wounds, effective antidote for phosphorus and cyanide poisoning, germicide and deodorant, used to bleach the hair, used for removing surgical dressings, hair lightening and deodorant, and a microbial agent due to liberated oxygen is reduced by organic matter, commonly used for disinfecting wounds and ulcers, used as a mouthwash. In dentistry, it is used for tooth whitening. It is used as eardrop for removal of wax. It is used as a mild bleaching agent to bleach silk, wool, ivory, hair, etc. So it is used in the textile industry. Then to restore the color of old and spoiled lead paintings as an oxidizing agent in the laboratory. Then it is used as a rocket fuel. It is strong antiseptic and used to clean the wounds. Then used as an anti-clor bleaching agent in textile industry. Then ammoniacal hydrogen peroxide bleaches human hair to golden yellow color. So it should be used as a bleaching agent. The next is the storage. So hydrogen peroxide solution should be stored only in a glass toppered bottle, and cork, rubber or metal should not be used for storing it as it will attack them. So plastic protected metal cap are used as stoppers, stored in light resistant containers in a cool place. It should not be stored for long periods. So in the presence of metal surface or traces of alkali, the reaction is catalyzed, therefore stored in wax lined glass or plastic vessels in dark. So usually it should be used in glass, wax lined glass or plastic vessels. It should be stored in a dark place. Urea can be added as a stabilizing agent in hydrogen peroxide. The next we are going to discuss about the assay of hydrogen peroxide solution. So it is assayed by permanganometric titration, or it is assayed the reaction is based on the redox titration. What is mean by redox titration? Oxidation reduction titration is called as redox titration. So here potassium permanganate itself acts as a self indicator. That means no need of external indicator. Endpoint is colorless to pink color. So principle, hydrogen peroxide in a diluted portion of the sample is quantitatively oxidized by titration with a potassium permanganate solution of non-strength. Compounds that are oxidized by potassium permanganate under acidic conditions interfere. 2K-4 plus 5H2O2 plus 3H2SO4 gives K2SO4 plus 2MnSO4 plus 8H2O plus 5O2. So 10 ml of the sample is diluted to 250 ml in a volumetric flask with purified water. Then take 25 ml of the solution and 10 ml of 5 normal sulfuric acid. Then the solution is titrated with 0.1 normal potassium permanganate until a faint pink color is obtained. So here KMnO4 itself acts as a self-indicator. So hydrogen peroxide and acidified KMnO4 both are oxidizing agents. So these two oxidizing agents reduces one another with evolution of oxygen. So hydrogen peroxide reduces potassium permanganate and produce decolorization. At the end point, excess drop of KMnO4 gives pink color. So KMnO4 itself acts as a indicator. So this is the method of assay of hydrogen peroxide by permanganometric method or by oxidation reduction titration method. So 2KMnO4 plus 5H2O2 plus 3H2SO4 gives K2SO4 plus MnSO4 plus 8H2O plus 5O2. സോ ഈ സെയിം റിയാക്ഷൻ തന്നെയാണ് നമ്മൾ ഓക്സിഡൈസിങ് പ്രോപ്പർട്ടിയിൽ പഠിക്കുന്നത്, അതുപോലെ തന്നെ ഐഡൻറ്റിഫിക്കേഷൻ ടെസ്റ്റിലും പഠിക്കുന്നത്. ഓക്കെ, താങ്ക് യു.